Hello everyone, this video covers problems 16 to 20 from Think Through Geometry. If you haven't purchased the book yet, I've included the URL in the description of this YouTube video. So let's go over problem 16. It says you need to find out the measure of the base angle. I don't know what the base angles are, but we have right isosceles, or some people call it as an isosceles right triangle. Well, let's just try to draw the picture. So here we go. We get the right isosceles triangle, and you can see that these measures are being the same thing. So these are called legs, okay? And we get the hypotenuse as well. So the opposite part of the hypotenuse, as you can see, the opposite part of the hypotenuse would be 90, and we call this as a vertex angle. Right, so what about these two angles? These two angle measures are being the base angle, so let's just try to mark it out. We understood that these are isosceles triangle, so it means that the angles are going to be, corresponding angles are going to be same, according to the IT theorem. You call this as x, you call this as x, and of course, this is going to be 90. Right, so according to the sum of interior angles of a triangle theorem, I call it SIAT theorem, these are x plus 90 being 180. Yes, so 2x plus 90 equals 180. So if you just do some little arithmetic, that becomes 90, hence x equals 45. So we have found out the measure of a base angle of an isosceles right triangle. Now we're moving on to problem number 17. It says, determine the measure of the vertex angle of an isosceles right triangle. So we first draw the right isosceles triangle again, and we understood that these are base angle. These are base angle, and these are going to be the vertex angle. So we understood that the vertex angle has some kind of like a mark that is a little bit right angle mark. We usually call it as a right angle mark. That is not round, right? It has some edges. And you can see that that has the measure of 90 degree. And of course, the answer for this number 17 would be 90. So moving on to number 18. Right. So determine the measure of an interior angle of an equilateral triangle. So what is an equilateral triangle? Equilateral triangle means that equi means that having the same, lateral means the side. So we have a triangle that has all sides equal. So we draw the picture, okay? We draw the picture out here, and you mark it out in that following form. Now, of course, we can consider this as an isosceles triangle too. If you apply the IT theorem, these measures having the same sides, it indicates the opposite angles are going to be same. And at the same time, if you apply the same type of strategy for the other two sides, well, we get the two sides that are equal, and the angles right here are going to be the same thing. So if you just apply all these strategies multiple times, or I would say 3 times, you can call this as x, you can call this as x, and these are also all x. So you add every value out there, and to get 180, that becomes 3x equals 180, hence x equals 60. So the measure of an interior angle, well, I gotta say all interior angles are congruent for an equilateral triangle. The answer becomes 60. All right, so number 19. Let's go on to number 19 and 20 and be done with this clip. 2 parallel lines and a transversal. So we get a 2 parallel lines and a transversal, right? Just like that. So let's just try to mark it out, okay? And these are the marks to represent that we get lines that are parallel. And we have a transversal. Transversal literally means that it's cutting through those two lines. And if a measure of an angle equals 45, I'm not sure where that 45 is going to be. Probably right here or there. I don't know, like one of those 4. And what is the measure of what is the measure of its alternate interior angle in degrees? So alternate interior angles are having the sides right there, or we get the sides right there. So I'm just going to call this as 45 out here. So these are 45, and I have no idea what that angle is, but I'm going to call this as theta, okay? So if you call this as theta, according to the alternate interior angle theorem, I gotta say, which is direct result from the corresponding angle postulate, we consider theta equals 45. So there we go. And you can also see that if you see the phrase about the alternate, it's usually having the opposite side from the transversal. Now, moving on to the consecutive exterior angle, which is going to be number 20. Given 2 parallel lines and a transversal, the measure of an angle equals 60. And what is the measure of its consecutive exterior angles? So consecutive exterior angles, it should stay on the same side of the transversal. So I'm going to call this as this one, or this one, or that one, or this one. So I'm just going to mark it out as 4 dots. One of the angles become 60. So I'm going to call this a 60 out there. So if you just like try to highlight what's going on here, I need to find out the exterior angle. An exterior angle usually sits outside those 2 parallel lines. And it should stay on the same part or same side of the transversal. So you can actually check that that becomes x. And these are what? So what is the relationship between these 60 and x though? Well, they're far apart, so they're not going to be a linear pair, but they are supplementary for sure. That's a CEA, consecutive exterior angle theorem. So let's just try to mark out that x plus 60 equals 180, and x equals 180 minus 60. That becomes just like 120. So hence we have found all solutions for the first 5 problems from number 16 to 20, and that's going to be it for this clip.